Yay! Math! Yay! Math!
With a marker.
Yay! Math! Yay! Math!
Ooh, color it in. And now to freak you out. Yeah. Okay, good. Got to hand it to you. Congratulations. It's always hard for a teacher to rev up the students post-quiz. You guys just took a quiz. How did it go?
Yay, Math!
How did it go? It's always a challenge, but I commend you. I applaud you for going from quiz to yay, math, yay, math, yay. Oh, what did you call me? A what?
Egyptian princess.
Mathema princess. I'm the Mathema princess to some, or the mathemaGYPTIAN to others. I'm the mathemaGYPTIAN. Please draw the following circle. Prior to doing so, I have one question. Yay, math?
Yeah!
Oh my God! You cannot rehearse that. That's cool. You're like, everyone telepathically communicate. Don't say anything. And now say it.
Delayed reaction.
That was cool. All right. Circle. Here it is. So the following has to do with tangent lines. Be ready. Please feel free to ask questions. All right. We're here to help you. If you have a question, then other people have a question too. Okay. So just ask it. Just speak up. You know. Here it goes. The definition of a tangent line is a line that intersects the circle at one point. So how can, let's actually put it in. Intersects circle at one point. So what type of line intersects a circle at one point? Does it go through it? Or would that be 2 points? Go ahead, say it. It's okay.
Well, wouldn't it?
I know you know it. What type of line intersects a circle at one point?
Radius.
No, diameter would go 2 points. wouldn't it? No, I'm talking about a straight line that goes on infinity. Straight line that goes on forever.
Oh,
So would that be 1 point or 2?
2.
2.
So
What?
like a little line.
A little line? What do you mean? Like
Like a
here?
little line that doesn't touch the edge. Like.
Now you're getting warm. You're getting warm.
A
Oh,
chord.
it goes out.
A line
It's
segment?
a line segment that goes on forever that touches the circle at one point.
A ray?
But it goes on
But it
forever.
wouldn't touch the circle. It would just go out of the.
So for example, does this line touch the circle at one point?
No.
Oh.
Touch the circle at 0 points.
So maybe a line that starts like
one of those.
no in the middle, but like
Touch
starts
the outside of the
yeah,
circle.
just,
Starts on the outside of the circle and then does what? Where's it go?
It goes through radius to the center.
not through it.
Not through
It
it?
just touches the bottom part of
Yeah.
the circle.
There you go. Just touches the bottom part of the circle. So it intersects the circle at one point. Here it is. Do we have a yay math drone? Yay math. Like walking the rest of the day like, hi, yay math. Hi. Hi, Pharaoh. Hello. This thing rides up, by the way. They don't teach you that in Pharaoh school. Okay, so a line that touches a circle at one point. Naturally, this could go on also, but I'm not going to draw that. All right, so this is a tangent line. So besides intersecting the circle at one point, it also has another characteristic, and that has to do with the radius. Can anyone guess what the relationship is with the tangent line and the radius? Please.
They're perpendicular.
They are perpendicular every time. So I'm going to put that down there. Okay? So tangent lines intersect circle at one point, and I'm also going to write perpendicular to. Hi. So fun to see people in the window. Perpendicular to radius. Okay. So now we have the ability to draw a right triangle, don't we? So I'm going to draw this line here. Now we officially have a right triangle. Oops. Okay. Suppose radius given is 3. Suppose this line is 2. Let's get the red. Let's solve for the length of the tangent line. Solve for x. Okay, let's give it a whirlsies. Okay, we already have hands, please. Nice and loud.
Okay, so then you can do the Pythag or Pythagorean
Pythag. We're gonna- By the time you leave this class, you're going to think it's called Pythag, the way I say it. Yeah.
Probably. And
Okay, so Pythag using what?
you can put the 3 where the radius is.
Which
from
one?
The far left line.
This one?
Yeah.
What about here? Can I put that here?
No.
Oh, can't I?
Wait. Oh, yes, you can.
Oh,
Yeah.
okay. Because I was wondering why, like, the, like...
Aren't
buttons-
all radii the same? Two, yes, I'm
Oh,
glad we
2
did
just
that.
starts there?
2 is this.
You
okay.
choose
Oh,
5.
no wonder.
2 is this. Yeah, I tried to center it. I'm glad you brought it up. Yeah, so 2 is over here. May I call this 3 as well?
Yeah.
Yeah.
Okay, so Pythag is your theory. Yeah, so
So then you can just look at it and you see a 3 and a 5 and you probably
It's
understand
4.
that the next one's 4.
yeah, good job. So indeed, you know about the 3, 4, 5 triangle. So tangent line is 4. All right, using the special triangle 3, 4, 5. Or you could have done Pythagorean theorem, 3 squared plus x squared equals 5 squared, solved, and you get 4. Okay? So that's the main concept. Let's do another. Oh, perpendicular radius. Erased it. Okay, another circs. Okay. Tangent line. And then you have radius. That's- Who can give us the rule? Tangent lines are always what with the radius? Perpendicular. Good energy, man. 8, 4,
Alicia has something.
okay. And what's the problem going to ask us for?
What the radius is?
What the radius is. What the radius is. Okay?
Still do Pythagorean.
Yeah, you will need Pythagoras. So we're asking what the radius is. Okay, theory?
No, I'm just wondering if, like,
Question.
they're, like, if you have to put the arrows on the end of, like, the tangent line. Because, like, it goes on forever.
Oh, no, we don't have to. We assume that it will, but we're going to use the triangle for working.
Okay.
Good question. Yes?
Would it be, if you use Pythag, would it be x squared plus 8 squared equals 4x squared?
Okay, you're close. So we agree that we don't know the radius, so we can call it x.
Or 4 plus x
So we
squared?
can call it r or x, whatever, but yes, you got it on the second try. Very good. Very good. So let's do Pythag. What's a?
X squared.
X squared. So we have x squared. What's b?
8 squared.
8 squared. What's c? The hypotenuse? Anyone? Everyone?
4 plus x.
4 plus x
Square?
squared. So I'm going to do x plus
Put it in
4.
parentheses.
Yeah, good job. X plus 4 squared in parentheses. That's something that students miss that you guys don't need to.
You
The
have to
whole
square both.
length. Yeah, you have to square the whole length. Okay. So begin. Elevator. Doop. All right. X squared. Silent. It's so funny. Plus, what's 8 squared? 64. What is x plus 4 squared?
X squared plus 16.
X squared plus 16, common mistake also. It's not x squared plus 16. I'm glad you said it.
16 plus 16.
So what should I write first?
Well, we have to do the parentheses first, so you don't know yet.
Right, so what should I write first?
4x.
No,
X
yes.
squared. X plus 4 squared. You don't know.
I already have that, but what should I write to help me do this easier?
16. The arrow. I don't know.
What does squared mean?
It's times 2.
Oh, X plus 4
foil
foil
it.
it.
Foil, so what should I write
So
first?
x plus 4 times x plus 4.
Yes, good.
Oh, yeah. I remember.
That's what squared means. Okay, take a second. Foil that up. Foil that up. Now it's fresh.
Do you hear music?
I do hear music.
This
All right, continue. X squared plus 64 equals
2x.
FOIL. Okay, x times x is
Square.
x squared plus,
4x.
right, 4x plus 4x. That'll be 8x. We'll write them both, why not? 4x plus 4x plus 16. Cameraman, is the 16 on the screen here?
No.
No!
Should I
Okay.
adjust it?
It's 16. Okay, and so let's bring it over to the left so that we get it all in the frame. Plus 64 equals x squared. What's 4x plus 4x inside? Plus 8x plus 16. Okay, and now what should we do?
Subtract x squared.
Let's subtract x squared, yeah, because 16, oh, we can do 16 as well. I'm going to do that both in one step. Minus x squared, and let's subtract 16 on both sides too, per your suggestion. Minus 16, and what are we left with?
8x.
Right, so we have 8x over here on the right, that's legit, 8x. 64 minus 16,
48.
48, good.
By
And
8.
divide by 8, x is 6. And looking closely, does this triangle look familiar?
3, 4.
It is another 3, 4, 5.
Wait, how is it 5? 5 is more.
3, 4, 5 times what? 3, 4, 5 times
Two.
what? Times 2. Yeah,
Oh, okay.
right on, right? 3, 4, 5 times 2 would be a what? 6, 8, 10. 6, 8, 10. Okay, moving on. Feeling good? No questions?
Great.
Protests? Wink. Okay. Good
That
job.
took me a while to get.
All right. Definitely support peaceful protest. This is in tribute to them. Could say that. And your history. No, not. The walking was cool.
Yeah, the walking's fine, not the.
Yay.
Yeah. That was like a working song.
Yay. Math. Yeah.
Hope the class blows the mind. All right, circle. Now, next rule for tangents goes like this.
Yeah.
I'm gonna draw a smaller one. You don't have to draw a smaller one. You can leave it as it is. Draw it a little below here. Okay, next rule. Now, what can you say about tangents Okay. What can you say about tangent lines that meet at a point outside the circle? What can you say about these two tangent lines? Best guess. What can you say about the relationship of these two tangents when they meet outside that automatically makes them what?
Equal.
Yeah. Right. All right. If two tangent lines meet outside, they are, by definition, equal to each other. And it sort of makes sense because the degree or the angle that they need to follow to nick the circle on the edge would have to be the same because the circle is perfectly symmetric. Thus, these two tangents would be the same
So
question.
how would you then define the rule, like in words, if you wanted to put it down?
I'm glad you asked. Let's do it. Two tangent lines that meet at a point outside the circle are, yeah, we can call it are congruent, equal, either one's fine. Congruent would be the line itself, equal would be the measurement of the line. Okay, so I'm going to continue this drawing. And we go down. and we go over, and we go, yeah, we're gonna make a triangle here. Over, over. Okay. Please assume all lines that appear to be tangent are. Please assume that all lines that appear to be tangent are. So I count 3 tangent lines. A 1, a 2, a 3.
Where's there?
3 on the left, 1 on the bottom, 1 here. Technically, you could say these 2 are both tangent, right? These 2 are both tangent, and these 2 are both tangent. Let's do some measurements. Top to bottom, we'll call this 5. Got here. We have here 2 and 4. Okay. Question we'll ask: what is the perimeter of triangle? What's the perimeter of the triangle? Okie dokie. Let's start with the easy one as I stand in front of it. Okay. What's easy about this, considering maybe this is 2? Go
Wait,
ahead.
well, all of them are equal, right? All the sides? Oh, no.
Maybe you mean what you, I know what you mean, but you have to be more clear.
Like 5, like all the like sides equal 5.
No.
So,
The
no.
corners?
Not necessarily. Very good guess, though. What do you think? If this is 2.
Corners.
Yeah, both tangent lines. So if this is 2, what
The other
else?
side would have to be 2.
Putting it in?
And then the top part where you originally do the congruent lines, that side would be 3.
Yes, because it's the remainder of 5. Good. 3.
And then the other side would be 3.
Subsequently, 2 tangent lines from the same point are the same. That's 3. Does it make sense? 2 tangents.
So then does that
Yeah.
have to be 4?
Indeed.
Oh, and
Down.
Oh.
Down. Wardrobe. Okay, what's the perimeter of the triangle then? What's this side?
6.
6 plus 5 is 11 plus 7,
7 is 18.
18. Okay, that's the perimeter of the triangle. All right. You want to do one more, or you want to stop there?
One more.
Get a handle one more?
Just for fun.
Let's do one more. Take these off. If you want, if it'll help you, redraw the same type of image.
And draw it straight.
Yeah. Draw a circle inside a triangle. Draw the same type of image. This won't take long now that you know it. And let's put them in. We have 12 here. Okay, I'm going to take this rule down for clarity. 12. We have 2z. We have 10 times z minus 4. I'm trying to make it abundantly clear. 3x. And 6 times 3 minus x. 6 times 3 minus x. Okay, now it's again going to ask the perimeter of the triangle. Okay, let's go one step at a time, real easy together. 12, 2 tangent lines from the same point are always equal. 12. What equals what upstairs?
3x, 6, 3 minus x.
Right on, 3 times, or 6 times 3 minus x equals 3x. Work along with me. Here we go. 18, 6x equals 3x. Add 6x to both sides. 18 equals add 6x to both sides. So 9x, very good. X equals 2. So let's go ahead and put it in. If x equals 2, what's this?
6.
6.
The other side has to be 6.
Other side has to be 6. Let's prove it. 3 minus 2 is 1. 6 times 1 is indeed 6 as well. So these are both 6. Last equation to set up, and we're done. What do you think?
2
So you do the same thing, but you
equals.
Do it with the z's. You got it. Take this off. Okay. Now we have 10 times, I'm going to go ahead and distribute right now. 10z minus 40 equals 2z. minus 10s negative 40 equals negative 8z. Divide both sides by negative 8. Z equals 5.
5.
Someone just turn on the TV or something? Yeah, okay, that's cool. Okay, so z equals 5. Plug it in and we're done. 2 times 5 over here is 10. Very good. 10 times 5 minus 4, I do have this 10. That's 10. Okay, perimeter, here we go. Where's the blue? In my hand. So this is 12. These two together make 12. These two together make 24. And then 12 and 24 and 20. 12 plus 24, 36 plus 20,
56.
56.
Sweet. Good job.
Does gravity work for the Pharaoh? If I drop these, will they hover?
Yes.
Yeah, doubtful.
You guys actually thought about it. That's what's funny to me. You're like, no, they'll fall, they'll fall. No, it's just a costume.
Or is it?
Magical Pharaoh body.
Look, they're not falling. This is my new favorite one. Pregnant Pharaoh.
Huh?
Well, let me just. Oh, let's do pregnant Pharaoh. Pregnant with a math baby.
What's that one's name gonna be?
I think I'll name him
Math of a baby.
Tangy.
He's a square personality.
Such a square. Oh,
funny.
my tunic broke. Water? Okay, never mind. Yeah. You guys are with it. Good job. The tunic did break. Okay, so please give yourselves a. And you guys did really good. Good job. Say bye.